So today's lecture is lecture number 14. So in this lecture, we will study briefly regarding mutual information and joint entropy. And we will address some of the questions, numerical problems from these two topics. So already we have studied the details regarding mutual information when you have two random sources, variables that represents random sources. And also we have studied joint entropy. We will be again revisiting that quickly, and then we will try to solve some examples from that. So here, some equations are given regarding mutual information. So mutual information between x and y is represented as I of xy is equal to entropy of the input minus the conditional entropy of the input with respect to the output. And then the average rate of information transmitted by the channel, which is represented as R, is nothing but the mutual information multiplied by the rate at which the information is inserted into the channel. Or in other words, we consider IXY is nothing but this term multiplied by R. Also, we know another relation that entropy has a property that it is mutual. Entropy here, that is I of xy, mutual information of xy is also same as mutual information between y and x. So this is the first property we investigated when we studied about the mutual information. This is one of the properties of mutual information, that is the entropies of input and output are, sorry, the mutual information of input and output are the same, equal. So now how can we define R? R in that case is nothing but the entropy of output, we need a bracket here, minus the conditional entropy of output multiplied by R. So basically this equation, I have...
Excuse me.
Yeah, please tell
Sorry
me.
to interrupt. Sean is not able to join. He's using SJC domain ID it seems, but he's not able to join the class.
Okay, so just a minute. I don't see any admits here. I mean, requests here. I don't see any requests pending here. I think I have accepted all the...
Wait a minute, sir. You have sent me the screenshot. Wait.
Maybe let him try again. Same link.
Okay, sir. Okay.
Okay, so now can you all see the screen? I mean, the PPT?
Yes, sir.
Okay.
So,
Okay. So, okay, so I was talking about the mutual information here. The pointer is, okay. So mutual information we discussed, and then we talked about the average rate of information transmitted, that is equal to mutual information multiplied by the rate. So how to represent the mutual information? That is based on the entropies or conditional entropy. It can be represented in this way. But also we have a property that mutual informations are equal, input as well as outputs. So we can also write the average rate of information R for Yx. That is nothing but entropy of Y minus the conditional entropy of Y multiplied by R. So that is based on this equation here. Since X, Y are equated here, that's the mutual informations are equated here, we can also write the average rate of information R same as the average rate of information similar to the output. Okay, now based on these equations, we will try to address the first question. So in the first question here, a channel is given here. So this channel consists of two inputs, x1 and x2, and two outputs y1 and y2. So here the first symbol x1, if it is transmitted, maybe it is received as y1 with the probability 0.8. And when x1 is transmitted, maybe this is an alphabet or a number or a video or a photo, something, any information, x1 is transmitted, it is received at the output as y2. Maybe y2 can be same as x1 or something else with the probability is 0.2. And then we have x2, another symbol. If it is transmitted, then at one of the outputs, it may be received as y1 with the probability 0.2. And if it is transmitted, then at y2, it may be received with the probability of 0.8. So this is the channel's condition. When the inputs are transmitted, and outputs are measured or outputs are detected, this is the setting, I mean the probabilities. Okay, now okay, let me continue. So here another information is given, that is probability of the input. Can you see all this? Can someone say? Reply to me.
Yes, sir. Yes,
Okay.
sir.
So Px1, this is what? It is 0.6. That is probability of x1 is 0.6. And probability of another input x2 is 0.4. And the rate of information R, that is how many symbols are injected into this channel. This is the channel, right? So between x1 and y1, or here we have a channel. This is a box, right? Maybe I should use the pen. And so this is basically the channel from here to here. Maybe a wired medium or a wireless medium. Okay. So this is the input point where the source inputs the data or symbols. This is the output point where we measure the output. Maybe if this is a camera here, then this may be a TV at home, right? Just an example. So then the channel is maybe a optical fiber cable or a free air wireless channel, because data is generated in some studio and we are located.
Excuse me, sir.
Yeah, please tell me.
So more than 5 to 6 members are not able to join.
Okay, I will admit them. So are they sending the admit? Because they know the link.
So
They just need to.
actually they said they are using the SGS email ID itself, but they are not able to enter the meet.
Hello, sir. I think the Google Meet number of participants is limited up to only 100 participants.
But I have 101. Is it?
Not sure, sir. In Google, it's given like that.
So in that case, right now I cannot do anything. But I'm not sure about this update. So, do they get any error message in that case? Alvin?
So it's like they are not able to join. They get the pop-up message that you are not able to admit or something.
Can they send again? Because I'm waiting for their request.
Yes, sir. They are keeping on. They're trying itself.
Okay. I'm just checking.
Like
Whether...
around 10 people have informed me, sir.
Okay. Okay, maybe it says, yeah, maybe 100 participants. I did not know this update. So I'm sorry about today's class. I mean, Maybe if that is the limit, then I cannot admit them today. But I will post the video link. Is that fine for them?
Okay, sir, I'll inform.
Because it's not in my hand. I cannot do anything right now, right? If it is 100 participants, earlier it was fine. So anyway, I will post the video link, and if they have any questions, they can come to me, no problem. I mean, they can contact me. Okay, so I think I will continue. I'm sorry about this happening. Because I'm still waiting for them. I cannot get any, I cannot see. I think every participant can see my screen. There is no request. If there is a request, I will admit them. So, but I don't see any request. Okay, Elvin, I think I will continue because other students also.
Yes, sir. Yes, sir.
So right now you can see my PPT, right?
Yes, sir.
Okay. So sorry for the interruption. And okay, here. Let me continue. So we have the inputs here and the outputs here. And between that, we have the channel. And probability of input is given here. And the rate at which information is injected into the channel is also given. Now with this, what do we need to find out? First, we need to find out the information, mutual information between X and Y. So this is in the same way we can find mutual information between Y and X. The values will be same by using 3 different relations. Okay, we will see what are those different relations. Actually, we have already seen them, but not explicitly. What is the relation? I mean, if you have noticed or studied this topic in detail, all the previous discussions, you will be knowing what are the 3 different relations. Anyway, no problem. We will see this in today's lecture. And also the second question is, find the rate of information transmitted in bits per second, rate of information transmission. So that equation we have seen earlier, right? So we need to apply those equations in this context. So right now, what do we have? We have only one information here. That is, we know the channel and the probabilities, and also the input probabilities we know. So with this help, with the help of this, we need to find out the mutual information. So you know the equation for mutual information, right? In the previous slide, mutual information is given. Mutual information requires the entropy values. So we do not have entropy values here to find the mutual information, right? So we need to find the entropy values. So, but we know if the probabilities are given, there should be some method to find the entropy, right? We have practiced this many times. So we will use the same thing here. First, we will write the channel matrix because we know the channel, what are the inputs, what are the outputs, and what is the transition probability. So with the help of that, we will write the channel matrix. That is probability of output, provided we know the inputs, input probabilities. So Pyx, that's a conditional probability of Y, is 0.8, 0.2, 0.2, and 0.8. Do you know how to write this? This is from the previous lecture. We have practiced this. Here, 0.8, 0.2, 1 row, 0.2, 0.8, right? Same thing is written here, 0.8, 0.2, 0.2, 0.8. Or to be specific, this is written like this, x1, x2, y1, y2. So we have x1 here and x2 here and y1 here and y2 here. Okay, so accordingly you have to fill these values. Okay, next based on this, we need to find out the entropy h of x. That's the entropy of the input. Do we know the probability of inputs? Yes, we know the probability of input. So entropy is nothing but minus pi log pi, right? So what is Pi? It is given in the question. Let me just go back to show you. Probability of input Px1 and Px2 are given. Based on that, we need to find out the entropies. So entropy is here. I mean, probability is here. The values mentioned in the previous slide at the input section. Those values you need to plug in and find out what's the entropy of the input. So that is basically 0.6 log 0.6 and 0.4 log 0.4. That should give us around 0.97. So this is how we find out the entropy of the input. Then how to find the entropy of output? So entropy of output using the probability of input. So probability of output is equal to, we know this is based on the channel matrix, right? So probability of output is equal to probability of input multiplied by conditional probability of output. So what is this? P of, probability of X. This is the input given, Px1 and Px2 in the input, right? Given in the question. Inputs probability 0.6 and 0.4. And what is this? This is the channel matrix. In the previous step, we have found the channel matrix, right? If you want, I can go back and show it. So this is the channel matrix, Pyx, and the other thing is Px, this one, Px, probability of the input. So we are multiplying these two parameters, these two matrices here to get probability of the output. So this is a well-known equation. Probability of output is equal to probability of input multiplied by the conditional probability of the output. So you know this simple multiplication here between two matrices. And when you multiply, you get two values here. Two elements in the resultant matrix. The first one will correspond to the probability of one of the outputs, y1. So second one will correspond to the probability of the next output, because output has 2 points. One is y1 and y2. Their probabilities are 0.56 and 0.44. So this gives us the probability of output. So if we know the probability of output, can we find the entropy? It is simple, right? The same equation, the general equation of entropy is nothing but minus probability of something that you want to calculate and log of that probability. For all the symbols, you want to calculate the entropy. So there are two output symbols, y1 and y2. For them, you need to compute. So right now we know the values of these probabilities. So one value is 0.56, the other value is 0.44. That means for y1 it is 0.56, for y2 it is 0.44. So you can find you can get the entropy of the output this way. And now you need to find out what? Joint probability between X and Y. Sorry, joint entropy between X and Y. So to find the joint entropy, we need to know the probabilities, because if we know probabilities, we can use this kind of equation to find the entropy. So let us first find out the probabilities, joint probabilities. With the help of joint probability, we will find the entropy, because entropy is nothing but probability log of probability of that symbol. Okay, right now we have here the joint probability of xy is equal to, what is this? For the input, some matrix, and then multiplied by the conditional probability of the output. So someone among the students, maybe Dikshit is here. Can you please tell me what is this matrix? Okay, Disha. Okay. Kavyashree?
It's a diagonal matrix.
Okay, right. So, okay, thank you. So that's the diagonal matrix for the input. So along the diagonal, we will have the probability of the inputs and other elements should be 0. Okay. So what do we know here? P of xy. So we need to find P of xy. So we have the diagonal matrix here. So in the diagonal along the diagonal matrix, that is mainly in the diagonal, we have the probabilities of the input symbols, 0.6 and 0.4. Probability of x1, probability of x2. Other elements are 0. So that is this matrix, and this is the channel matrix. Channel matrix is given here, and just multiply, and we should be getting the probability. I mean, joint probability between x and y. Right? So, can someone tell me what's the answer here? What's the answer for this multiplication? We should be getting another matrix, right? When we multiply this and this. So can someone tell me those values? We have 1 minute to find out this answer, because that value is required for us in the future computations. Because next we want to find out the entropy between joint entropy between x and y. So how to find out that? That is nothing but probability, log of probability. So probability is here. What is that? That is joint probability, right? Between x and y. So we are computing this for every input symbol as well as every output symbol. That's why we have the double summation here. One to calculate the, I mean, one to keep track of the input, other one is to keep track of the output. Since in this case, we have same number of inputs and outputs. Otherwise, in some cases, maybe you have 2 inputs and 4 outputs or 3 outputs and so on. In that case, accordingly, this summation will vary, and that is much more challenging, such kind of problems. Okay, now, do you have the answer for this?
0.48.
Let me write down. Okay, 0.48. Okay, so the first
0.12.
Okay. Okay. 0.1.
0.08.
Okay.
0.24. Rows are
Sorry,
rows are 0.48 and 0.12. Next row is 0.08 and 0.24.
Okay. So next one is 0.24. Right? Okay, maybe this is right. So these are the values. Maybe you can just verify those values. Thank you very much, and I will give you 0.5 marks. So please send me an email after the class claiming your bonus point. So may I know the name of the student?
Ashika, sir.
Okay, please send me an email after the class. Thank you very much.
Okay, sir.
So it looks like these are the values. So you can just verify that. It's a simple multiplication of 2 matrices. Okay, then these values will be useful in the future while finding the entropy here. That's joint entropy. And next I move on. So based on that equation, the values she mentioned 0.48, 0.12, 0.08, and 0.32 or 24. Please verify those values, and when you substitute there, you should be getting around 1.69 bits per symbol. So that is the joint entropy between x and y. Okay. Now we need to find out the conditional entropy between, I mean, conditional entropy of the output y when we know the input. How to do that? do we know this parameter? Probability, I mean the joint conditional probability of output. Do we know the conditional probability of output? So the conditional probability of output is nothing but the channel matrix itself, right? And do we know the joint probability? That is what we found. The student helped me to find the answer. Just verify it, the last number, and use that right answer. Okay. So since we know these parameters already, we will move towards finding the entropy, which is the conditional entropy of output. So what is the equation to find out the conditional entropy? Conditional entropy is nothing but probability of joint probability multiplied by the conditional probability, right? So this is the equation to find out the conditional entropy. So here again you have two summations, one for the input and other one for the output. So these values we already know, and this also we know, right, from the previous matrices that we have determined. So just we need to insert those values here: 0.48 log 0.8 and 0.12 log 0.2 and other values here. That is based on the previous matrix P of xy and conditional matrix. This element and this element, this element and this element, this element, this element, and this element, that is P x2 y2 multiplied by the same corresponding element here. So when you add up all these, you should be getting around 0.7219. Please verify these values. I recommend you, because these steps, what I mentioned here, they are right. But you need to verify these values, whether these values also right. So I can give you a direction here, how to calculate these values, what equation you need to use, and what's the meaning of this equation I can explain here. And we will try also to find out these values. But you need to carefully plug in the values at the right places here and verify that whether these values are right or not. Okay. So if someone is computing, can you please tell me whether this answer is right? It is 0.7219. So that is the conditional entropy of the output. Okay, with this I move forward. Right now we have another entropy, that is for the input, the conditional entropy of the input. So for that we know this equation, that is joint entropy of the input and output is equal to the conditional entropy of the input plus the the entropy of the output, right? It is similar to the previous equation where we found h of yx, right? Okay. Now for the conditional entropy between x and y, I mean conditional entropy of x, when you know y is equal to, is it just rearranging this equation here to find this parameter? Are we doing this minus this, right? That is what done here, because we already know the value of this as well as the value of this. We can just substitute here and find out the conditional entropy of the input. So that should give you around 0.7038 bits per symbol. So this becomes a value of this parameter h of y conditional, so x conditional y. Okay, now we are coming to the main part of the question. The first question was to find out the information, mutual information, right? I of x comma y. So we know this equation, I of x comma y is equal to entropy of the input minus conditional entropy of the input. So that is equal to this. See, because we know all these values. This value we have found in the very first step using the probability of the input px1, px2 is the input given in the question. Using that, we found this parameter, right? Summation of pi log pi for all the input variables. And this value we found here. So just find the difference between these two. That should give us this value. So that is the mutual information between x and y. And also, the mutual information between x and y is equal to this form, right? Entropy of the output minus conditional entropy of the output. So that is also the same value. Third, mutual information between x and y is equal to entropy of x, entropy of y minus joint entropy between x and y, right? So that's what written here. So because we have all these parameters determined in the previous steps, because the first question was find out the mutual information between x and y using 3 different relations. So these are the 3 different relations that help us to find out the mutual information between x and y. That's why we found many of these parameters in the previous steps, because we can directly use those values to plug in at these positions and find the answer. So my first question here, the first equation here, the second equation here, what is the reason behind making these 2 equations equal? Because mutual information between xy is equal to this. That is the first equation. Also, the mutual information between x and y is also equal to y. I mean, entropy of y minus the conditional entropy of y. So, is there any specific reason to say that this equation and this equation are equal? Do you remember? I can give you a hint. We have studied this concept 2 lectures before. And then my next question is, so first and second equations are, we say they are equal. Then why this is also equal to the third equation? So what is the theory behind this? So can someone answer? So maybe.
By properties, sir.
Very good. So what's your name?
Kirtana.
Okay, send me an email, okay?
Okay, sir.
Thank you. So 0.5 marks for your answer. So this is by the property. We have studied these properties in the 2 lectures, I think, before. So this says this is a mutual, right? And another property that says this, the sum of the individual entropies of input and output minus the joint entropy of input and output. That's equal to the mutual information between x and y. So these are based on the properties that we have studied. Actually, we have studied 3 properties of mutual information. So that is what is written here, equated here. Okay, that's why all these values becomes equal. I mean, because of this relation, you can verify this in any given setting. So this is a verification here. I mean, we have a question here, example 1. And in that example, we found different parameters and then when we equate it, all these values becomes equal, right? So there is a theory that says these relationships between the mutual information. And in this example, we inserted different values to these parameters, and we have noticed that these values are equal. Okay, so this is just the verification of those properties. Okay, the second question, find the information rate, right? So to find that, we know some equation. So here, the rate is given, that is 1000. In the input, it is given, right? Multiply by this parameter, that is okay, h of xy, 0.2651, right? So here, letter is missing. Okay, so we multiply these two parameters and we get this value. Okay, that is the first question. Now we are moving to the second question. So I want your participation in this question. Okay, I will call some of the students to answer my question. So in this question or in this example, we have another channel. So in this channel, we have two inputs and how many outputs? There are 4 outputs. Okay, so now the transition probabilities are given from x1 to y1, x1 to y2, x1 to y3, x1 to y4. These are the different values. Similarly, for x2 to y1, y2, y3, and y4, the transition probabilities are given. Using this and also the input probabilities here, you need to find out some parameters. First one is find IXY, that is mutual information between X and Y using 3 different relations. So I mentioned already what are the 3 different relations. They are basically from the properties. Next, find the rate of information, I mean transmission, that is R, you need to find out. To find that, the rate at which information is inserted into the channel is given. So again, you need to use the same equation. So I want everyone to participate here. So right now this is given. So what is the first step? When the channel is given, you find the channel matrix. I want someone to answer me the give me the channel matrix here. Can someone try? So may I call Saurabh? So is there Austin? So is there Aishwarya?
Yes, sir.
So do you know what's the value?
0.6, first row,
Okay.
0.1,
Okay.
0.1, 0.2. In second row, 0.2, 0.2, 0.1, 0.55.
Okay. Okay. Thank you. Thank you very much. So is it something like this? So this is the channel matrix, that is conditional probability of output when you know the input. You know the input probabilities very well, x1 and x2, what's the probability, but you're not sure about what is the output probability. So we compute the channel matrix, that is the conditional probability of output when we know the inputs. And then what's the next step? What would be the next step? Using this, we need to find out different entropies, because our main question is to find out IXY. So to find out that, we have an equation, right? In that equation, we have all the entropy terms. And also it says that you have to find out using 3 different relations. So of course you need the conditional entropies as well as joint entropies, and also the individual entropies, h of x, h of y, conditional entropy of xy or yx, and the joint entropies, h of x comma y, h of y comma x, all those you need. So we will try to do that with the help of probabilities. Okay, now we will find out h of x. Since we know the probability of inputs, we can find out the entropy of the input h of x. So can someone tell me how to find h of x? You just tell me the equation to find out h of x. Maybe may I call Austin? Okay, no problem. So I call Bindu. Bindu is, can you answer? Okay. So Angelica,
Yes, sir.
yeah, can you answer this question? How to find out h of x? It's okay if you just try, okay, later. So may I ask Kriti? Okay, so okay, this is the equation to find out the entropy. Okay, pi log pi, because we know the value of pi, right? See, just go back and check here. We know the values of the probabilities inputs. P of x1, P of x2 is 0.6 and 0.4. With the help of these probabilities, we can find the entropy of the input. Okay? That is what done in this step here. And then, of course, we have inserted the values and found what's the entropy value. And now, entropy of output. How to find the entropy of output? So do we need some relation with the conditional entropy? Yes. Do we know this conditional entropy of the output? Yes. Do we know the probability of input? Yes. So then it is easy to find probability of output, right? Since this parameter P of x is the input given, and this is the value that we have determined using the given channel, we can just substitute those values here to find out the probability of output. So this is the input, probability of the input, and this is the channel matrix that we have found using the diagram given, right? And then we can find out easily by the multiplication of these two matrices, P of y. There are 4 values here because the output has 4 points, y1, y2, y3, and y4. That's why we have 4 values here. These are the probability of occurrence of the output, y1 to y4. y1 is 0.42 and y4 is 0.34. So that is what mentioned here. Probability of y1 is 0.42, probability of y2 is 0.14, 0.1, and probability of y4 is 0.34, and so on. And next, entropy of output is equal to what? Pi log pi with a minus sign. Okay, we have these 4 elements in the output. So just these summation 4, and you just substitute the values of these probabilities and you should be getting the entropy value y. So here we have this, that's equal to 1.784 bits per symbol. So please verify these values because we know all these values. We just need to calculate these values and find the sum of all those values. And then we will move on to find out this parameter, that's the joint entropy between X and Y. So JPM refers to joint probability matrix. That's equal to, yeah, probability, that's a joint probability between X and Y is equal to the diagonal matrix of the input multiplied by the conditional probability of output. So this value we can easily get it because it has probability of the inputs along the diagonal. We know what are the probabilities of the input px1 and px2. It is 0.6 and 0.4, I guess. And this matrix we already know. And then we just substitute here, and when we multiply, we should be getting some value like this. That is nothing but the joint probability between X and Y. Hope this step is clear to everyone. Maybe I ask, okay, no need, I will just tell you here. So we know this value, that is probability of Yx, we know this, and also the diagonal matrix. So P of Yx we know. So PD of X is what? PD of X is nothing but it's a diagonal matrix. So PD of X is a diagonal matrix consisting of Px1 is 0.6, right? Given in the input figure, 0.6, I guess, and other one is 0.4, that is probability of X2, 0.4, and other values here in the secondary diagonal are zeros, multiplied by this value. This value, you know, in the previous slide we have computed that matrix values. Okay, you multiply those two and you will get probability of, joint probability between X and Y. So what's the value? The value is here. Okay, then joint entropy is what? Joint entropy is equal to joint probability log of that probability, joint probability. So we know here all the required inputs, they are here. You just need to find out those values here. That summation here. So that is nothing but 0.36 log 0.36, 0.06 log. For all these elements, you need to find out pi log pi. Okay, and that should be around 2.5861 bits per symbol. Okay, then I move on to the next step, that is conditional entropy of the output. Here we have probabilities. We know the condition, we know the conditional probabilities. So these are the values, conditional probabilities. Using this, and also we know the joint probabilities that we have found in the previous step, right? So then finding this is very straightforward. So that's equal to, that is the entropy, conditional entropy of the output is nothing but joint probability multiplied by conditional probability of the output. So we have here,
Sir?
please tell me.
Can I see the previous slide, sir?
Yes. Here. So you have any questions here? So basically, basically this comes from here. This term and the log of that term. So those terms are here. 0.36 log 0.36, 0.06 log this one, and the last element is 0.22 log 0.22. You just add all those terms. You have totally 8 terms. You just add it, and you should be getting here. And then we move on to finding the entropy, that is condition entropy of the output. So to find that, we have the probabilities, conditional as well as joint probabilities we already have, but then now we need to just substitute those values in the equation. What's the general equation to find out the output's conditional entropy? That is nothing but joint entropy. Probability of joint entropy sorry, joint probabilities log of conditional probability of the output. So these values we can get from where? Here, right? These values. And then this value, where is it? Here, right? So just we need to substitute those values here, corresponding values, because we have two summations, one for the input 2 symbols and output 4 symbols. When we do that, it should be looking something like this, 0.36 log 0.6. That is 0.36 log 0.6. Next one will be 0.06 log 0.1 and so on. The corresponding elements we are considering. The last one is 0.22 log 0.55, like that. Last one is 0.22 log 0.55. Okay, just this is a simple addition here. When you add them all together, you should be getting the value something like this. Then similarly, you find the conditional entropy of the input using this equation. Okay, so some of the values are known here. This is the equation finding h of xy. Then some of the values that we already know, so we can write joint entropy xy minus the entropy of the output. That gives us this parameter that is written here. Okay, so these values, of course, we have ready in hand. We just substitute here and get the value. Okay, then finally coming to the last step, that is information between, mutual information between x and y using the first relation, that is entropy of the input minus conditional entropy of the input. The second relation is with respect to the output, the entropy of the output minus conditional entropy of the output, and then combination of first property and second property, that is h of x plus h of y minus the joint entropy between input and output. So this is how we find the IXY for all the three cases. Yes, someone having any doubts? Okay, I move forward to the next step. That is the second question. Find out the information rate. That is R multiplied by I of XY. I of XY values are same for anyone you can take, this value is same. So R is given in the question, that is how fast the information is injected into the channel. So this is altogether the average performance of the channel. This is actually the small r represents the rate of information entry into the channel, and this is the mutual information. When you multiply these two, you get the average information being processed through the channel. So it says even if you send 1000 bits as an input per second, since this value is very low, at the output, on an average, you only get 168.9 bits per second. So this is the amount of information that is processed through the channel. The input may be very high, but still, because the channel is not so good, channel has a lot of error, right? Channel will introduce a lot of error. As a result, when it is propagates through the channel, you can get only about 160 or 169 bits per second. So that is what the practical scenario is. When in case of a wireless medium, if you consider maybe mobile communication, even I say when you download some PDF or some video, you should be getting about 1 Mbps or so. If I say, then to make you to get 1 Mbps data rate at your side, I should be transmitting maybe at 10 times of that or more than that, because if I transmit with so much data rate, then when it propagates to the channel, because channel will try to degrade, introduce some errors into the data. As a result, the final output will be very less than that, because channel is not ideal. Okay. So you may get 1 Mbps. That means at the transmission side, the base station might have sent it at a very high rate of 10 Mbps or so. Okay, so this is, I mean, just I'm relating this result with the practical scenario.